Okay, TS2 Environment and Energy. This is going to be the last of the exercises relating to looking at your house in terms of environmental performance, and we're going to kind of look at two things in this which carry on from the last exercise involving use of Diva, which is a plugin to Rhino. We're going to look at it in terms of internal daylighting and the relationship that has with sunlight and solar control. So I hope that at this point you will all have built the model of your homes akin to the model of my home that I've built, and I hope that the detail of this model is sufficient, not too much, but sufficient to allow you to do this exercise. So just to recap, the model of my house, I say, is fairly crude and fairly simple, but adequate for this. And the key thing I need you to have, and you probably already have it, is a level of detail which is captured in very few layers. The only layers that you should have are, as I do, I'll walk you through these. Let's turn these off. Really 4 layers that I've got. One is the external fabric of my house. One is the internal rooms of my apartment, I just being the ground floor only. I've got the glass on a separate layer, that's really important for this. And then I've put the surroundings on another layer outside of that. So that, as you probably noted in the last tutorial, was important for using Diva in terms of that layer logic. So what we're going to do today is quickly start by looking at the internal illumination, that's the daylighting levels in one of your rooms. So to do that, the first thing you need to do is set up a view. I've already set up a view in mine, but there's a few ways you can do this. The easiest way tends to be to turn off everything except the inside layer. So that's, for me, is that the 3D walls inside. So this is my apartment, and would just simply position myself inside the room that I want to, and this is the bedroom which I'm going to look at today. And usually what I would do is, once I've kind of got into that space, I would go to View, go to Set View, and then Set View, and then under Named Views, I would then save a view, Save As, and I would tweak that view in a couple of ways. When you set up a view, that camera will the properties of that camera in terms of its focal length, all these things you can play with. If that number is lower or higher, it'll change the view angle, and just the position generally. So I've done all of that now, and the view that I have, which is Jonas's room, is already set up, and I've set that up so that what is captured in my room, if I turn on the layers, is all of these key things. Not very much detail, but I have put a table in there, which is what I want you to do as well. I'm actually just going to put that table on the correct layer. I'm going to move it to a new layer, 3D furniture. And I will just move that to 3D furniture. Okay, so essentially the first part of doing this exercise requires you to simply replicate what I've done, which is to replicate a view in your room. And I do want you to have one piece of furniture, no more than one, as simple as you can, in that room, preferably a table or something which has a working plane on it. Okay, once you've set that up, again, the process for using Diva is super simple, and the steps are the same as they were last time. I'll just run quickly through them. I'm just going to turn that to layers so you can see. Location, again, any environmental simulation requires a location because every environment is different. In the previous tutorial I've told you how to download the location file, or the EPW file for London Gatwick. So if you haven't got that, go and look at the previous tutorial. So that's just a question of clicking on that and putting it in the right folder, which is the C Diva folder, again all explained in the previous tutorial, and pressing OK for that. We're not doing nodes in this, so we're just going to jump straight to materials. And again, materials under assign materials. All we have to do is assign materials to each of those layers. This is the reason that we have such a rigorous layer layout. So I've already assigned materials to glazing. I've assigned materials to walls and inside walls, and remembering that these numbers here represent the reflectance value. So the higher the number, the more reflectant. I have white walls in my house, so I've given them a reflectance of about 70. So the only one I haven't assigned a material to is this table, which I just put on a furniture. So I'm going to assume it is kind of immediate reflectance. So we'll just go generic furniture. The reflectance is about 50. And then when you've assigned all of those reflectances, you can just submit material information. So that doesn't change anything in your viewport, but it does mean that now Rhino and specifically Diva know what materials it can take into account when doing simulation. So the simulation that we're going to just do this very quickly is, as before, this Diva window pops up, and the one that you're going to look at is under daylighting images, visualization. Last week we looked at radiation map, so under visualization. So this is, you could just simply go with this immediately, just run simulation, but I'll just tell you what some of these are. Image quality relates to how long you want to wait for your simulation. I think for these submissions that I would like to go for the medium quality, that should be enough, but just to make sure it works initially, go for the low quality. I'll just do low quality now so you can see. What is important is a question of the sky condition. Now usually when we are doing daylighting, we would always look at an overcast sky condition for a very simple reason. We want to know whether when it's a miserable day in February, whether we have enough daylight. So I'm going to go with what's called a CIE overcast sky. So I'm going to click on that one. Once you go for the overcast sky, then it's kind of a generic grey sky condition. Date and time don't now matter, so that's fine, so you don't need to touch that. You've got the perspective, but you could change and look at fisheyes if you wanted to, and the current perspective view is what it's going to do. So you can have a play with these. This is also something you can play with. For the moment I just want you to do render luminance image and tick that box. If you want to know more, click on that and that'll tell you everything about that. Don't worry about this, they're all just radiance inputs which you don't need to play with. You can play with the image size if you want, and really don't worry about any of these either. So all you need to do is press run simulation. Now as before, when you press run simulation, this dialog box will come up, and then you have to wait. You have to wait till this gets to 100%. So I'm going to pause this for a second. Now once that has reached the end of its list, which just took me about 20 minutes I think, and if I'd gone for a higher resolution it would have taken longer, but at the end of it, no matter what you pick, you'll get to an image, and that image should look what it should look, I suppose, something which I don't want to use the word photorealistic, because obviously this doesn't include any materials, and that's important because it is a measure of when we say illuminance, it's a measure of light falling on a surface rather than light bouncing off a surface. So everything appears grey, and that's very often how we want to look at things, because we want to understand if there's enough light falling on a surface. What surface? Well, maybe the surface of a table, such as this table. And if I just make this big, the good thing about this software is this is what makes it different from if you just did any rendering in any other software. When I click on this one, it allows me to assign values to places where I might be interested in the illumination, like the tabletop. Can I actually read a book? Well, I can read a book. 500 lux is a number that I've mentioned to you, but actually I could quite happily read a book in 200 lux. So can I read a book in this room on this table? Yes, I can. Could I sit under the table and read a book? Well, probably not. And really that capacity is really important for us to understand the performance of a room in terms of daylighting, and it's a function of many of the issues I've discussed in terms of the size of the window, transparency of the window, the proportion of the windows of the buildings outside of that window, and as a result of that the relationship to the sky and essentially the source of light. Now, the other thing you can do in this, which I'd like you also to do, is it's very simple. If you click on false color, we can change this image to a different type of visualization, whereby we're not looking at a grey and then a series of points, but we can look at a color range. So if I press that, convert to FC, it will now change this image in a different way, and I can alter the scale of that. If at the moment it's looking at Candela. Okay, so this is looking at luminance. Anyway, let's just go on that. If I reduce that number, the upper range, what you'll find is that it will change the scale and give you much more variance in terms of the kind of colours that you get. So it's worth having we play with this to see, by changing those scale, what you can, what kind of image you can get. So that is the first part of the lecture. You can obviously save the image as you want to a JPEG file format or a BMP file format. So they're the first two things I want you to do. So we're going to quit out of that. Right, second part of this is what I want you to do is to look at the relationship, I suppose, between daylight and sunlight. So the exercise we've just done looked at how much light shines through your window when there's no shading on your window. Now we've already looked at why one might need to shade a window. This comes down to the question of solar gains. And what I would like to just very quickly do to illustrate that relationship is to model a very simple shading device on one of your windows, and then see what the impact of that is on the daylighting. So in Rhino you can do shadows very easily. So this is again my house. I've gone back outside, and the way in which I can turn on the sun in Rhino is if you go to Render Tools. Again, we're in Rhino 5. I forgot to mention that you do, for Diva, have to be in Rhino 5, the 64-bit version. If you go to Render Tools and go under that sun panel at the far right, it will bring this up. Now, Rhino is quite clever in its simplicity, I guess. So I'll just quickly talk you through how to turn everything on. Just turn on the sun, press on, and then you can essentially pick the time, just press now. You can pick the place, just press here, and both of those things will bring you to London now. So that should turn on the sun. I'd also do one other thing, which is pick a ground plane. You may not have modelled a ground plane in your model. I didn't in mine, so just press ground plane on, and that will assume there's a ground plane. So let's get rid of that. So where are the shadows? Why are there no shadows here? Okay, well, the shadows are I've got this set to show shadows only in the render mode. I'll just turn them on here. If I go to rendered, there are shadows. Now they're really terrible shadows, like they're really poor quality. I'll just go back to this guy here. I mean, I can move the shadows around by so I can see it's definitely moving the sun, days and months. I see it's definitely do that. But why are the shadows such poor quality? Well, the way to address that is in Rhino. What you have to do is if you go to File and then go to Properties. I don't know why they make it so difficult, but all that you have to get to is one of the options under Properties, Rhino Options, under View. You expand that, and it shows under different display modes what the settings are. So the display mode I'm interested in is the rendered display mode, and one of the options under that is if I expand that, is shadows. So under shadows, this is the tab that will define how good your shadows are. At the moment it's set to the minimum grainy shadows. I'm just going to throw that right up to give us maximum sharper shadows. And there's a few other things you can do. I will let you play with that yourself. So let's just do that now. If I now look at my shadows, now they're much more clear, and then if I change hours, or that's change the month or change the hour, I can now much more effectively understand the relationship of surrounding buildings to my windows. Now, that's pretty easy. It'll take you 10 seconds to do that. What I want you to do, which is a little bit more tricky, is I want to understand when the sun shines in a particular window of your house. Now, to do that, there used to be a way to do this easier, and there may still be a way, but I say the program I used to use this is no longer around, so I'll have to do it a slightly more laborious way, but it's good for you guys to learn. What I want you to do is pick 6 months, so January, February, March, April, May, June. The other 6 months will be the inverse of this. I want you to pick a window. Now the window I'm picking is my bedroom window, which is this one here. I'll just show you that again. It's this guy here. And the reason I want to pick that one is because I know from experience that this window does receive sun for a very specific time of the year. But when? I think this is important to know, because if we know when it shines in, then we know when we might need to design solar control for. So what we're going to do is we're going to use this to essentially, on a month-by-month basis, try and simply map out when sun hits this window. So this is the month of January. I'm just going to play through the day. Does this window ever get sun in January? And I'm just going to say the center of my window. And the answer is the center never does get sun. So there's no solar access in January. Let's try February. In February, just playing through the day, start in the morning, I can see that the first time the center of my window gets sun is about 11:30, and it's got sun until about 12:30. Okay, so I know that in February I've got about 1 hour solar access. Let's try for March. I know that in March, if I just play through the day, I can see that that window gets sun, the center of the window, from about 10 past 10, and it remains in sun till about 12:30. Okay, so having figured out when the sun shines in your window with that manual way, which we've just done it by turning on rendering, turning on the sun, and simply allowing our shadows to track past our window. The question is there a better way to communicate that information? There is, and the better way is to use this diagram which we looked at before, which is a thing called a stereographic diagram. So there used to be a way to do this through a program which unfortunately no longer exists. So we're going to do it in a slightly more conventional way, as I've given you a file which is that same diagram but in AutoCAD. Just to remind you what it is, and if you look back through the lecture notes for lecture number 2, you'll see it very clearly. The diagram looks like this when you open it up. These concentric circles represent the angle above the horizon. So you may remember, if I was on my back looking at the top of the sky, that is the top of the sky, and then these concentric circles represent what we call altitude angles. That's angles going down in degrees of 10 degrees from the top of the sky to the horizon, 10, 20, 30, 40, all the way up to 90. The points of the compass represent the north, south, east, west, obviously, in terms of where the sun is. And then across that mapping of the sky, in terms of, we say, altitude, which is the angle above the horizon, and azimuth, which is the angle from north, it describes where the sun is in the sky. So we can tell that if we take this solid line here, which starts there, tracks all the way across to there, that's a line for January. And it kind of makes sense, because in January, the sun rises at what time? Kind of a little after 8. The sun falls at what time? Just before 4 o'clock. And on the way, which is a short day, as you can tell, and the highest the sun gets, which is about this point, is what degrees over the sky? Well, it's that's the horizon. That's 10 degrees, so it's about maybe 15 degrees over the horizon. We take June as a comparison, which is this line, again solid line up here. The sun rises much earlier, about just after 4, and sets much later, just after 8. Remember, this is without British summertime. And again, its angle in the sky is very different. Not only does it rise at a different point in terms of the horizon, but also it achieves a much greater angle. How high does it get? Well, if we follow our concentric circles, it's not 90, it's not 80, it's not 70. It gets to about 62 degrees in terms of the height over the horizon. Okay, that's just a quick reminder of how this diagram works. So all I want you to do now is simply map on the solar axis to your window. So we do my window. I told you that in January there is no solar axis, nothing to map. In February, if I come down and I'm just going to turn off my snaps here, just so you just draw it a little easier. The February, my solar axis from I think we said 11:30 to 12:30. So I'm just going to draw a line, a little circle. So February 1st, I keep going down until I reach 11:30. That line is 11. See the solid line intersection. This line is 12, so 11:30 is about halfway between the two. So I'm just going to draw a quick circle there. And I'm now just going to keep copying circles. So the next circle is when sun sets. Sun sets in February at 12. Oh, it doesn't set it. Sun stops seeing my window at 12:30. That's an hour later. That goes there. And I'm going to continue doing this. The next month is March. The sun sees my window at about 10:15. So I'll throw that 10:15 on the March, and then the sun stops seeing my window in March about 12:30. In April, this line is it's a kind of a cyan in this, but just don't worry about that. That's just the way it imported into AutoCAD. But in April, I've got from 10:30 to 12:40, just about there. And I'm being quite crude about this, but it's adequate just for the exercise I want you to do. I just want you to understand how to use this diagram. So May, I've got from about 10:40 to 13:15, so there's my 13 line, 13:15, and then finally in June I've got from 10:50 there to about 13:30, which is about there. So if I were to connect all those dots, just again, I'm not doing this as snaps, I'm just doing this quite easily. I now begin to understand an area of the sky. I just hatch that. So I'm just hatching that so you can kind of see that. Select. Just throw that to the back. That's a kind of an area of the sky that my window sees, and I can tell when the sun will shine within that area. That's why we use stereographic diagrams. They allow us to understand that relationship. Now the last thing I want you to do, which is super easy, is to design a sunshade and see the impact of that sunshade on the first thing we looked at, which is the daylighting. We're just going to do it for the most extreme condition, which is June, but I'll let you decide based on your window what obviously you need to design for a point in time that the window is in sun. So I'm just going to take June, and as I said, to understand what a window shade might have to do in June, I have to understand where the sun is at that point. So if we follow the solid line of June down, as we've said, at 12 o'clock, which is this point here, the height above the horizon is not 90, 80, 70, 60. So let's design a shade that can cast a shadow when the sun is at 60 degrees. So I've just, to the right of that, just done a very simple section of my window, which is about 1.7 high. You might want to alter this for your window. And all we're saying is that, just turn on my snaps again, to cast a shadow for 62 degrees, which there's 62 degrees there. How deep is my my brise soleil going to have to be? Well, I'll just measure that distance here. Oh, if I can remember the command. About 877. So let's go 900 mil worth of canopy over my window. Okay, that's super easy to do. Let's just quickly do that in Rhino and see what happens. So I'm just going to go back to shaded. I'm just going to very simply draw a 900 mil canopy here, just over in the corner here. I'm going to make it solid the way I usually make things solid. I'm not a Rhino master by any stretch of the imagination, but I usually go to the surface tools and I use this surface and planar tool curve. That makes an element solid. And I'm just going to move that shade to the top of my window here and just rotate it around so it is correctly aligned with respect to my window. And I'll just simply move it over a little bit, just so it just relates to my window only. Okay, that's a bit crude, but you get the idea. I put a shade on my window. Now, does that shade cast a shadow in June? Well, let's just see. Let's go to render it again. Let's go to June, and let's just cycle through the day. Does it cast a shadow on my window? Well, pretty much. There's the shadow it casts. And maybe it needs to be a wee bit longer, but fundamentally that would block most of the solar gain. Okay, so that's kind of it. You can really do any shape you so choose, but I just want you to understand that relationship and the sequence of work. The last thing I want you to do is repeat the first thing I asked you to do, which is we're just going to go to the save view we have, which is set view, which was Giles' room, which is the one we set up, which is the one inside my room, and we're just going to rerun the Diva rendering. So nothing should change. All the materials should be assigned already. If I press on that, so there's the only thing is I've put the let's just fix that. So I put the new shade on a layer which has no material assignment. So okay, well let's just do this. We'll just go back into that. I'll go to materials again, assign materials, and I'll just give it a material assigning. I probably should have put it on a correct layer. So that is going to be, I've put the shade on default layer, so I'll just make it a white shade. Let's make it a white shade. High reflectance ceiling, so that's fine. Submit material, and then all we're going to do is again do what we did before, which is run a simulation. So clicking on metrics, this comes up again. Daylighting images. I'm not going to change anything. Let it do its thing. I'm just going to run the simulation. Okay, and let this do its thing again. It gets all the way to the end, and essentially when we get to the end of that, I just want to compare what the difference in terms of daylighting before and after putting that sunshade was. Okay, and that will show up again, and if it shows up again, then you can do the same thing again, which essentially I want to see has there been a discernible reduction in light levels as a result of putting that. So I think what I want to just see is those two images beside each other and see if the impact of doing a shading device has measurably reduced the level of daylight in your room. Okay, that is it. So if you guys can do that, there's a lot more to this, but hopefully you will manage to understand how you can start to look at daylighting in your spaces and make decisions around that. Okay, good luck.